Hey, how are you all? So today we are going to uh, code kth level nodes of a binary tree. This is a very, we can say, nice question where you are gonna learn about like printing elements of the kth level. Okay, see, the k is our 3. This is the first level, we can say. This is the second level. This is the third level of a binary tree. So what we want to do is that we are required to print the elements in the kth level, that is 3 third, that is we need to print the elements like the 7, 4 and 5. Okay, or how are we going to do this is by using a function, using recursion, you can say. First of all, first thought, why? Because it is easier for us to do this in this binary tree. We have seen that the recursion is the most easiest thing you can do in the binary tree. So let us first of all break it into simpler problem. First of all, so let us first of all write the function. Okay, void k node print. Yeah, let us write this type of function where we will be passing the root and the k. Yeah, it will be int, and the root is our obviously node star because it is a node which is defined by us. Okay, let us break it into simpler problem. That is the root only. That is our, see, we'll be starting like the k is 3. Okay, k is 3. 3 minus 1 is 2 and minus 1 is 1. So if k equal 1, yeah, that means let us think that the k is 1 and we are at the level 1 only, and we are given 1, k equals to 1, and we have to just print the values of roots data. Yeah, this is the simpler thing you can think of. Yeah, so and just written. And another best case you can think very easily is that root null. If root is null, then what? Then we simply return, no need to do anything. There is nothing you can print. There is no need to print that. Okay, now let us think how we are gonna proceed if k is not the 1, that means it is something like 3 or 2. Then how we are gonna proceed into this? We are going to call the same thing, yeah, again and again, but for roots left part, yeah, and k would be reduced. Okay, for roots right part, and also k minus 1, not k minus minus, k minus 1 is what? Yeah, what is the time complexity? See, you have just, let us the time complexity is like n times n times you are moving to the elements to get the elements. Okay, so n nodes are there, let us think, and you are traversing through n nodes to get the to print the elements. Yeah, I think this is all we have to just think. Just get print and root and pass no k, sorry, k. I think we are gonna get the answer. 4 and 5 is given to us. But 7 is also our answer. Okay, sorry, we haven't changed the pre-order sequence. 1 2 not -1 to be 7. Yeah, 1 2 7 -1 I can say, -1 then left part, okay, and right part. Here it will come by -1, then part 3, 4 -1, okay, 5 -1. I think now print 7 4 and 5 is our kth order nodes, elements, or data, or value, we can say. That's how you solve kth level nodes, or we can say the values. Okay, let us solve this question. LCA, lowest common ancestor. Okay, this is a very nice question. Here you have to think little bit. First of all, let us see an example. Okay, yeah, first of all, what is an LCA? Let us see. Given a binary tree, find the lowest common ancestor of two given nodes in the tree. Okay, there will be two nodes that is given to us. Yeah, okay, and we have to just find the lowest common ancestor according to the definition. Okay, lowest common ancestor is defined between the two nodes P and Q as the lowest node in T that has both P and Q as descendant, we can say child. Descendants, yeah, child, where we allow node as a descendant of itself also. Okay, got it. Yeah, got it. Nice. So that means the LCA is something, the first node, which is P and Q are the, like the subtree exists. First node where the P and Q subtree exist. Okay, like for example, if we can say 5 and 1 is the our PQ, then 3 is our LCA because it's the first node which has P and Q as is subtree. Okay, also ancestor can be that is node is a descendant of itself also. Okay, see, let us take this example 35627. See, it can pass through the root also, otherwise it can also pass through the, not pass through it. No, this is not the thing. see, P and Q are 5 and 1. Okay, 5 and 1. Okay, 5 and 1. 5 and 1. Okay. Okay. So 3 is our answer. Okay. Now next question is 5 and 4. Where is 4? Here it is. So 5 would be our answer because it's the like is the ancestor of 4 also, and it is ancestor of itself also. Okay, 1 2 P is 1, Q is 2, the 1 be the what. Okay, let's simplify it very very nicely. Okay, yeah, like the base case, like the simpler case, we can say, if what happens is that the root is P. Yeah, if P's value, how to check whether it's similar, it's P's value and root's value are same. Yeah, or we can say Q's value is equal to root's value if any of them is true. Like for example, you have got the like the root and the P is same. Okay, example, this is our P and Q is somewhere there. We do not need to find this because if it is this is ancestors as children's, so the ancestor would be always the root only, so there is no need to find the other thing. So return root if it is a root, if any of them is a root, and we just have to be returning that. We do not need to find the Q, we do not need it. Another base case that can come is that our root is null. Then what to return? What to return? A root is null. If the root is null, then return null. Yeah, two best cases we have just learned. Like, you have to just understand the pattern. The pattern is similar. We are writing the root is null, then what do you have to do? We are finding that roots, if the thing is the root, okay, like simpler thing, then what we are doing, like first break it into like the we have got the thing as a root. Okay, then what you do, and then you move on to the next left part. Yeah, left part will say, I don't care about naming because it doesn't matter much. Yeah, and we are calling the function roots left part. Yeah, roots left part P Q. Similar way. Oh shit, just find it for the right part. Yeah, and it would be, yeah. Okay, now for backtracking you have to just see that, see, it can be possible that the both left and right part are null. If it is null, okay, both are null, then You have to return any of them, null only. Okay. If one is null, another is not, then what you have to do? One is null, another is not. If there is any example, no. Okay. Can be possible. One is null, another is not. Then what do you have to do? Then you have to print. Then you have to just um, let go the null part, and you have to just see the only what the left or right part depends. If both of them are not null, if what I've said, if left part and right part, okay, not null, then we have got what we wanted. Yeah, then just return the root because we have gotten it. Else if one is see, one is our valid and another is not valid, then just return the valid one, that is left part. Else case would be this is not null, yeah, or we can say both are null. In both the cases you can just return the right part. Yeah, you have understood what I have tell you. It's a very nice, very nice. We can say this is a backtracking. When you are backtracking, when you are going back, okay. For example, we can take example of 1 2 3 1 2 3 4 5 8 9 6 7. You have gone to the left part, you have found found something, then you go to the, you have found something p or something, oh yeah, to just return it, any of them, return it, because you do not need to find q in this portion, because if you have found the thing, two cases comes, if it is here and children of it, otherwise it can be in the another part, right part we can say. For both the cases you do not need to find, because can just return the root, okay, just return the root. If you haven't find the right, but it will be in the children only, okay. We have just, what we have just done, let us again recap it. What we have done, we have first of all, we have just written this thing, what, that is any of them p or q we have found, okay, at first in the left part only, left part doesn't matter, left part right part, we have found p or q in the root only, okay. Then what happens, return only root, because it is children, doesn't matter where it is, it will be, the ancestor would be p only, because it is the what, it is the because in the question it is said that node can be descendant of itself only, okay. So one is there and the children, so it is the lowest common ancestor, okay. Then we have written this thing, that is if root is null, if root is, there is two base cases come mainly, okay. One is this, that we have found it in the root only. If that is root is null, then we have to just return null because nothing is there, null, just return null. Okay, and then we have found the left part and the right part from the root's left part and the right part. Four things can occur. P and Q are found. Okay, no, uh, things came that left part is not null and right part is also not null. Just return the root because both are not null. That means return the root. Yeah, if one null another is not null, then return the non-null part, and both are null or both are null, then need return null only. The backtracking case, like if we take example like this. Okay, 3. Okay, it will not occur. Then 5 we have found P, then return that thing 5 only. No, return root. Okay, return 5 only. Then the right part, 1. Okay, it is return 1. Okay, now we have come return root, so 3. That's how you are getting this answer. Mhm. 5 and 4. Okay, 5 return 5, 1, 0. Null, return null. Okay, then it's right part, left part, null, 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 null. So it has written null and it has written 5. So 5 will be our answer. Thank you.